Chapter 26, Problem 11. A concave spherical mirror has a radius of curvature of magnitude 20 centimeters. Find the location of the image for object distances of 40 centimeters, 20 centimeters, and 10 centimeters. For each case, state whether the image is real or virtual, upright or inverted. Find the magnification in each case. All right, so here I've drawn somewhat badly the situation. So you have a concave mirror. You have an object at some distance here. You have the radius of curvature of the mirror, so that's the center of the sphere if this guy was going around there. So the focus is half that. So just for some practice, I'll draw again the principal rays that we're trying to approximate here. So you see how it ends up here, but here if we were starting over, we'd do something like this. Here's our mirror, here's our focal length, here's our radius of curvature. And in the first scenario, the radius of curvature is what? 20 centimeters. The object distance is 40 centimeters away, so it'd be somewhere like out here. And here's how you would draw the principal rays. A ray that comes in parallel to the straight line gets bounced by the mirror down through the focus. And that's a terrible drawing. Absolutely horrible. All right. The ray that goes through the center of curvature goes in and then back out along the same line. And then finally, a ray that goes through the focus gets bounced out in a straight line. So where they all intersect is approximately where the image should appear. So what would happen is if you have an object here, you have your mirror here, if you put a little piece of paper here, the image would appear on that piece of paper. So it gets reflected off the back and onto the paper. This is why it's a real image, because it's out here in the real world. If it was over here on this side, it would be a virtual image and nothing appears on the paper. I'll try and demo this for you in the video at some point. Okay, so those are the principal rays, and that's how you do this kind of problem. But now we're going to stick to the algebra because it's a little bit easier to handle and a little bit less difficult on my somewhat pained hand at the moment. So our first problem, we were looking at an object distance of 40 centimeters. So we have our mirror equation, 1 over p plus 1 over q equals 1 over f. P is 0.4 meters. We know the focal distance is r over 2, the radius of curvature divided by 2. So in this case, the radius of curvature is 0.2, divided by 2 is 0.1. So we then can plug in the right variables into this equation here. 1 over 0.4 plus 1 over q equals 1 over f, which is 1 over 0.1. So we can solve for 1 over q. That equals blah, 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 blah. Do all the algebra here. 1 over 0.1 minus 1 over 0.4. Get common denominators, and that becomes 3 over 0.4. So Q equals 0.4 divided by 3, which is 0.133. The magnification is, again, minus Q over P. Q is 0.133 divided by 0.4, so it's minus 0.33. Negative, so it's inverted, and it's smaller than the original image. We can do the same for the other images, and we'll get to them shortly. Also, it's a real image, and how do I know that? Because it appears on this side of the mirror, not this side of the mirror. I think those are the questions they wanted you to answer. So this is the first part of this problem. I'm going to upload this in several parts because it's very long.